guys, what's up? Welcome back to this brand new video. I'm super excited to kind of get deep into this concept because I've been stuck here for like so long. Let me just close it off. And what is this, bro? Close this off as well, bro. I'll tell you something. Let me tell you something. By the way, why is my camera looking like so weird? Let me just put this one here. And as well as is my audio getting recorded? Recorded, Queen. Let me check it. Yeah, it's getting recorded. Okay, before I move forward, okay, let me tell you a very cool thing. I try to, get this divide and conquer, and later on in this video, we'll be saying about like the search. And I was taught in class in my first semester of doing BCA that how to what's a binary search and shit. I didn't give a fuck because the way it was taught was like vomiting. But I had some rough idea about like what it could be like. It was like dividing it into half and dividing that into further half, and my brain was like recursion. Oh, that hard topic because it was made hard for me. It is still hard for me because I've not discovered like what recursion is. And I was saying like a function calling another function again and again. Like I couldn't even think of a loop. Okay, like even though I just I cannot show my door. Like I pasted a plastic and I was just trying to scramble. Like how can I reach? The fucking thing is this is the naive approach, going one after the another, and that's a good, bro. Why I'm laughing like a maniac is like it's not even my first thought. I'm like, yeah, that is the way we can do it. Like iterate through the entire array, and this is a naive approach. This is a linear search. This is a damn thing. This is a common thing, bro. Do you access the index of a certain element in an array? It's a common thing, like time complexity of O of n. But the binary search, which we'll be seeing in this video, kind of a bit because the instructor which I'm learning from said it like no need to focus on how we reach to this and how the time complexity of log of n. It's not like not n and log of n. Like it looks like it's like kind of n not log of n. How did we reach it? Still I don't know how did we reach it. I have a feeling it's like it's have a time complexity of O of n. My head is like yeah O of n maybe, but it's like time complexity is log n. Here it's a binary search. Okay, like binary search like Bi means two. Nary means nary. Nary is the name of a person. I don't know. Basically, what we do here, we place two pointers at the very beginning and the very end of our array, and then we come to the middle. Okay, suddenly we come to the middle. It becomes a one pointer, and we just yeah, that's how. Basically, there were no 2 points at the beginning. Basically, we create a one pointer using the two index places like the very beginning of the array and the end of the array. We combine them, divide it by 2, and in some cases you might get point number in points. So what we do here, we just round it off using math.floor function, and yep, so we get an integer, rounds off to the nearest integer dot math.floor, as you can see here. So we get to the middle place, like approximately a middle place in your array. If it's an odd number, so for sure you'll get to a middle place. If it's an even number, you might get to middle. Not, you can't get to a middle, so you'll almost get to half middle right or half middle left, so it will shift towards what that number could be like after approximation. So it's not middle, but yeah, we are somewhere in the middle. Somewhere in the middle is the word. So what it does, you have to really look into this code carefully, which I'll be explaining at the end. So before coming here, and yeah, so what is like having a naive solution is fine. O of n is not a bad um, time complexity when n is 1,000 or 100 or like let's say 10,000 or like something. So it's bad at 10,000, but at 1,000 it's okay kind of, but at 100 it's way fine. But if it becomes million, what if the array size is million? In that case, I don't know if an array can take that much of input or not. My friend told me like they can't, but there are vector arrays or something that can take. But I don't know much about them. I'll be learning about them in the future. Maybe we will be learning. I'm not teaching you anything. I'm just documenting my process. I'm excited about seeing all of these things. That's why I'm here. Okay. Without moving forward for further ado, let's just get into it. Divide and conquer. This pattern involves dividing a data set into smaller chunks and repeating a process with a subset of data. Let me just show this. Let me just write it down here. Okay. I don't know if we should be using this, but okay. Like imagine this is the data set. Okay. You divided this data set till this region, and you're dividing again this on this region on certain condition. I hope you can see it. God, I can't fix it. Okay, you understood, right? Dividing it further until unless we reach a certain condition, so a certain result or expected result, or we don't even find our result, so it returns a default result if you can't find a result after going through the very end of our process. And this might you have heard in the definition of divide and conquer. And it's not a made up term, it's like a registered term, it's like a documented term, it's like it's present in the books. Okay, it's a standard terminology, divide and conquer. Okay, the continuously divide up on a continuously divide a certain thing on a certain condition. Basically, that is divide and conquer. Until unless we reach a result, or we just run out of our data set like that. Yeah, get it right. So this pattern involves dividing. We got to read that set of. Let's move forward. Okay, this pattern can tremendously decrease time complexity. Wow. Tremendously. Yeah, and I told you right. Tremendously. Like it's like a fucking genius thing. It's just like incremental, decremental um, decrease in time complexity. Anyway, so an example. Let me just place myself here. An example. Give an assorted array. Oh yeah, by the way, these all things like all these searches kind of a thing works on sorted arrays. And even moving further there, let me just tell you something. So basically, we have 7 different sorting algorithms. Quick sort and merge sort basically uses divide and conquer algorithm. I don't know if 7 or 6, but let's say 7 for our safe number. Okay. Oh, what the fuck are my eyes? They're going lazy or something. I don't know. Binary search. I'm like tired maybe. Binary search trees also use divides and conquer. So we don't know what a binary search tree. We'll be going very deeper into them, like very advanced topics. So I don't know even if we can like talk about it right now. So that was all about it. Let's move further while reading this. Given a sorted array of integers, write a function. Oh, by the way, yeah, this should be sorted. Then and only then we can apply all these kind of weird ass tactics of divide and conquer. That accepts a value and returns the index where the value is present in the function is located. If the function is not found, return -1. That's the default value. If you run out of what? You just run out of your array, out of bound, -1. You're not, is not found in the array. And that's it. So what basically it does, for example, here you are giving n as 4 and you need to search like where is there n present. Yeah, n is present here. And what is the index or what's the position in which n is present in the array? So 1 is at 0, 2 is at 1, 3 is at 2, 4 is at 3. So the array's index of 4 is 3, so it should return 3. Similarly, -1. Why -1 here? -1, as you know, is a default output. To be like, what if an element has an array index of -1? Fuck you, bro. It's not possible. Arrays are 0 based index, so it cannot go beyond 0. Beyond 0 and backwards, kind of. You know what I'm saying, right? So, okay, this is the timer for start writing for my assignment. Like out of like he'll kill me if he sees with me an assignment that's not signed. I have a practical exam tomorrow, but who cares? Let's just keep waiting, and we'll do it the entire night. We'll watch movies. We'll finish the assignment, and we'll come to college tomorrow. Bye. F it up. Anyway, stop it. So you get my point. Like for example, 5 has an index of 6. 6 has an index of 5. Like 0, 1, 2, 3, 4, 5. 0 base index, yeah. Clear, right? Clear only, bro. Please say clear. This is a naive solution. What we do here, we use the function keyword and we write our function name. We can name anything, but we have used for good obvious reason so that people can understand what this function is about. Search, and the search is called linear search. Linear, like in straight line search. There's no bakwas. And we have array1 as a parameter and val1 as our second parameter. Array1 will accept array and val will accept a damn variable. And this all can be put by I'll pause this while explaining and I'll just type this and I'll show you also. It's a good thing to show things. Okay, anyway, so basically we have used a for loop which starts from we can use a for off loop here as well, but starts with 0 and runs through the length of the array, and every time iteration happens I is incremented with 1. If the array1 is equal to val, then simply return I. Okay, if it is not present after even iterating through every time, the for loop has expired. In that case, after it has done executing this part, it will go to this return part because because this return statement was never hit, so it has to hit a return statement, otherwise this function will be undefined, return undefined as an output, which is not an error, but basically it's not defined, so it will go through return -1. Anyway guys, so this is linear search. Let me pause and let me just write a code for this and I'll come back. I'm kind of scared sometimes, why is this phase in my heart, like, you're such a lazy person, you're just copying the code and you might not be able. Sort of listen to me, okay? You will be able to write when it's needed. If not, then you will go again and again, fail again and again, and you will reach there. Right now, it's not necessary. Just be happy. You're just gaining knowledge, and I know you'll do it. Don't worry. I'll come back after typing the code. As I told you, I have a habit of complicating things. So as I told you, we can use for off loop here, like as if like ha, it's so easy. For off loop actually returns the value, precisely the value, not the index of the value. You understand that point, right? So we have to use this like this. Let me just comment out the traditional linear search. Let me just show you this one. So similar only, but instead the code gets changed here. The for loop, yeah, you are using for off loop here, but the thing is we have to take in an array of two values, index and element, and we have to, so basically arrow.entries creates um, two values. Basically it produces the index as well as it produces the element, so we are trying to capture both using these variables. Okay, and if the element is equal to the value, whatever the user will input, like, yeah, I need to find the index of this, so it will simply return the index from what we have captured of that element from our arrays. Okay, for that particular for loops iteration. Yeah, it's kind of like, I don't know who will use this, but I don't know why I'm showing this. So that works, okay? That God promised that works. I have no strength to show you again. So here is an assorted array, and you can see there are like 6 numbers. Are you fucked up? It's like 7 numbers. Yeah, there are 7 numbers, and the last one has having an index of 6. So what we'll do, we'll just change it and we'll set it to like 1. What is the index of 1? 0, right? So let's just run, coming as an output 0, as you can see here down there. So yeah, crazy, it's working. For example, I want to search for 9, which is not in the array. So we get -5, -1, which is not in the array, as I should return -1. You can return anything, a curse word also, but I'm not excited to do that right now. And I'll go back here. I'll come back here. Hopefully the video is recording. Yeah, it is. So here is the refactored version of this linear search. That is basically a binary search here, and we set the first pointer, left pointer, right pointer. Let's say like left and right, minimum and maximum. We are setting it to minimum to 0, and let's name it left pointer and right pointer only. Minimum left pointer to 0, right pointer to the very end. And this, we have used a for loop. Instead of for loop, we have used a while loop. And my head, it is like, cannot we do it using a for loop? Good question, right? We'll try. While, like, anyway, why am I thinking like that? So we are setting like keep doing this. Keep doing what? Keep doing whatever is inside this till the time minimum is smaller than or at least equal to maximum. Hmm. 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 That is 0 and whatever is the length. So they become equal till the time minimum is gradually coming and becoming equal to the maximum, or it is less and it's like trying to reach to the maximum. Like these many times iterations are happening of searching that very thing. Division is happening, we're continuously dividing it. This many times iterations are happening. So till that time, keep doing the inner process. What is the inner process here? By the way, after showing this, I'll show you what kind of weird ways I was trying to reach to this situation, to this solution. I'll show you that also. I failed because I did not put much efforts into it, because this was using basically this only. Almost most of the logic is same, but This logic is gone crazy here. I'll show you what logic I'm talking about here and as well as there. Let middle is equals to math dot floor and min plus max, basically add them both, whatever is the default value in the first iteration, and divide it by 2, and whatever nearest integer value that will be kind of in the middle or almost in the middle, depends on if the array's length is even or odd, will be in the middle or almost one of the middle elements. Okay, one of the elements means if there is an odd, if there is an even number, though you will be having two possibilities of this could be middle or this could be middle. So it will select the more which is, which after rounding off it will select one of the either of the middle values. Let me just be confident about that. So let current element is equals to array at middle. Okay, so I don't know why did we even set this current element, because we have not even used the current element ever here, have we? No. So we will use it here. Well, I'll refactor my code according to current element. So the current element, I think, is for understanding purpose. So I don't know why it's not even understanding purpose. Like, it's very clear. So array at the middle. So array index at middle. So it will give us the middle element as a number. It will show us the number. If that number is smaller than the given value by the person, so what we need to do is to update the minimum value with middle plus 1. Why? It has two reasons, because as you can see that the value is smaller than the middle. So it's like smaller than the middle. So smaller than the middle. It's like more towards the left side. So what we are going to do is we are basically updating the current value of minimum, which is 0 index, to 1. Okay, why are we doing that? I don't know. We're just doing that. Why? What about the max? I don't know. Why are we doing that? Should I tell you? We are doing that to basically not run into an infinite loop, because min and max, if they are constant all the time, then there is basically no updation. Yeah, we are gonna continuously divide, but that division is also based on minimum and maximum. You see that? This is very crucial to add minimum value to middle value plus 1. I'm sorry for fucking it up. And what is else if that is like the maximum value, sorry, the middle element is greater than the given value to find. In that case, what is happening is that if this is the middle value and the value to be found is what is smaller than the value. So what we do here, if the middle is here, if okay, for example, the maximum was at the very end of the array, right? So what would happen? It will just reduce one step further. Okay, so reducing one step further, and then what we are doing, I don't know. Like, it has a many purpose to subtract, because yeah. So yeah. So the current value used anywhere, no. So return here, and otherwise else if it matches that the value and the middle value are matches, just simply return that. So yeah, what was I saying? In maximum, what happens? Maximum thing is updated, subtracted, goes back. Yeah? So what is happening is the middle value of the array. For example, this is the middle value, the center it is. So this is smaller. This is greater than the value to be searched. Okay, like here. So what we are doing right now, you should understand, okay, if you look into the very statement after the while, is a let statement having middle as the variable. So every time middle is getting divided, so don't worry about that. So yeah, so we are at the center, and that we have got a value which is smaller. We have got a value which is smaller than the middle element. So when you want to go on the this side, on the left side, so in order to go to the left side, negative charges are there, left side. So just -1. Hmm. Else simply return the value. Or if like you fucking run out of the min max, that is you run out of your entire array iteration, you like literally went through each and every places this condition took you, and you still could not find the array element, so simply return -1. So I will be writing this code and I'll come back after that. Okay, and I'll after that show you what weird ass thing I wrote. I mean, let me just show you here only. So what I did was use a while statement with weird ass conditions, and I don't want to even think about it right now. But I know if some new question comes, I'll end up doing the same mistake. Um, but the funny thing is, it worked. Some of the code ended up working, but it was very complicated, unlike what I'll be writing right now. So it does the same task of what I was trying to achieve, and I'm proud of these people who have got there. So we'll do binary search, and I'll come back after writing the code. Okay guys, we are back after writing the code in binary search, but a little bit of refactoring, which was necessary from my side, I thought. So we have written a function keyword after the search, and after that the function starts from here and ends still here. At the end, you can see we have tried to log out the result of what will be the index of 4 in this damn set of array which is sorted. It's quite clear the way I'm speaking today. So at the very beginning, we are defining two arrays, two variables, left and right. Let me just tell you, like, one pointer is here, left one, and the other pointer is here, right one. Okay, you're understanding it, right? Left and right. Yep, left and right. Yo, left and right. So the good thing is God is so blessed that He gave me the idea of how to do it almost like 90% and a lot of actually 100%. I wasn't mentally clear, I could have got it. But okay, sometimes we can refer things. It's okay. Sometimes we'll get hit harder by reality that, oh, I should have done it on my own kind of thing. Oh God. My rice, my potatoes are almost getting burned. Okay, let me just quickly finish this. So we have clear set a variable called let in the while loop. Okay, by the way, after the while. Okay, left and right we have set two variables. Left is set to 0 index, like for the very beginning, and right is set to the very end of the array. Get me, I've said it 100 times by now. The left and the right. So we have used a while statement. While statement starts here and it just ends here. Okay, and it has a condition. As you know, while statements have conditions. So even if this condition is not even true once, it will false, but it has to be true because it's not an empty array. If it is an empty array, for example this, it should straight up result -1. So it will result -1. So it is required -1, but it's not an empty array, it has value inside it. So left is 0 and right is 6. Okay, so 0 is greater than smaller than 6. For the first iteration, when it is smaller, when it is 0, it will run and it will set the center. So it will set our center value, which is gonna be right plus left divided by 2. That is right plus left. What is the right? 0 plus 6, right? Right. Why 6? Why not 7? Because it's -1 there. Divided by 2. That is 3. So center is set to 3. Like 0, 1, 2, 3. If you're gonna find the array at 3, you're gonna find 4. So 4 is actually the center of this array in our case. Okay, so we are setting the current element for this first iteration to be 4 using center as our variable. And anyway, so it's cool, right? It is. So what happens in this case is you are checking if the 4 is greater than equal to is smaller than 4. The answer is no, it will not get in here. 4 is smaller than 4, no. So it means else 4 is equal to 4, then simply return center. So the current value of center is gonna be 3, so the output of this should be 3. I don't know why did we take such an output. Yeah, 3. So it just returns the output in the first iteration itself. So crazy. Okay, we should select some other numbers, but before that let me just go and switch off my gas. Not actually gas, my cooker. It's gonna take a lot of electricity. I'll come back. I have to write a lot of assignment. Not gonna fucking lie. 14 assignments. 14 what? 14 programs. I will just write it. I'll watch movie and write it. Please pray for me. Okay, buddy. So we are back. What was I saying? Yeah, so we took a very crazy case. Like in first iteration only we got output. Let's go for something that shouldn't find. Let's go for 5, which is on the right side. So we'll guide you through. So it should return like 4 as an index because it has an index of 4. Complicated, right? So yeah, what happens for 4? The first time it is set to 4. What happens for 5? First time it is set to 4. The current element is 4. Oh, what is the current element? It is 4. So is the current element smaller than the value? The answer is yeah, it is. So where is the left pointer right now? So the left pointer, as you can see, where is the left pointer, by the way? Oh, by the way, left pointer was on the right side. Eh? Where is the left pointer right now? Acha, right now. Yeah. So the left pointer was at 0, right? Yeah, the left pointer was at 0. So it's still at 0. It's still at 1. So it is saying uh, you just set the left pointer. Uh, you just add the center value to this, which is 4, and add one more to it. What? Add one more to it. Yeah, add one more value to it. So basically you're saying the left pointer is now at 5 because it's not 4. That's oh crazy. So he's pointing towards 5 right now. Okay. And what about the max value? The right one. Right is still at the very end. Don't need to worry. So we have this array to now work on. Okay, like what about else statement? Fuck you, it will not get executed. What about else if statement? Fuck you, just here only, bro. Okay. What about fuck you? We are still in the loop. We can't run the return statement. Okay, I see that. I see that. Now the loop gonna run one more time. So can you just check for the condition right now? What is left? Left is set to left is set to 0 1 2 3 4. The left is set to 4, I guess, and the right is set to 4 4 hai. 5 6. The right is set to 6. The right is set to still 6. Yeah, of course it was previously also 6, so it's still 6 only na. So yeah, right is still 6. So this condition is satisfied. Like yeah, this should run once more. So what it does again, the current value of center. What was the current value of center? It was 0 1 2 3, which was 4. Okay, so when 3 divided by 2 is nothing but 1.5, and math.floor gonna make it 2, so it is like 0 1 2. Okay, not here. It's not. We are not going through here right now. No, we're not. So where are we? We are not. Okay, what is the current value of left right now? It's actually 5, so it's like 0 1 2 3 4. Oh yeah, the current value of 5 is 4. So 4 plus 6. What is 4 plus 6? 10. 10 by 2. 5. Yeah, there is. Where is our current center? Okay, 0 1 2 3 4 5. So we are at 6. Yeah, we are at 6. Okay, so the current value 6. And what about what we have put 5? So 5, yeah, 6 is greater. What again? 6 is greater? No, 6 is not. 5 is not greater than 6. Yeah, so this condition, if it's not done, let's go for if else. Yeah, this is true that 5 is smaller. The current current element, that is actually 6, is greater than 5. So what happens is that the current value of right. What is the current value of right? The current value of right was the sixth only, right? Yeah. So what we are gonna do right now? So we're gonna return two. We're gonna add in the right two, which we're gonna give 6 plus 2 8 minus 1. We're gonna give 7. So what the fuck? Minus 1 now. What the fuck is going on? What is the current value of center right now? सेंटर है फिलहाल के लिए लेफ्ट प्लस राइट. And I don't know, I forgot everything. Basically, you understood the point, right? So it will reach there. I don't know why am I explaining it in depth. I'll be explaining that in depth in the coming videos. Till then, take care, be safe. I love you so much, and till that time, keep DSAing. I didn't fail to explain. I did kind of got exhausted, but it's okay. You got the basic idea, the how it works. You got it right. I'm kind of a slow teacher and slow learner at the same time, but we just keep DSAing till then. Take care, be safe, lakab. Take care, be safe. Love you. Bye.